Quick recap from the last video, but if you haven't seen it, stop this and go watch it because this isn't going to make any sense if you haven't seen it. But congruent means the two figures are exactly the same. Okay, meaning that all of their parts are the same. And we're dealing with triangles, so those parts are going to include three sides and three angles. That everything is exactly the same. But in triangles, we only need three of those parts to figure out if they are congruent. Okay, and yesterday we learned that you could have three matching sides, or we could have a side, an angle, and a side matching up, and that'd be enough to say that those triangles are congruent. Today we're going to learn two more. Angle, side, angle, which we abbreviate as ASA, which looks like this, meaning that if two angles, here and here, and an included side, meaning that the side is in between the two angles. So when we're going, we're not saying angle and then skipping all the way around here and going angle, side. It's not angle, angle, side. It's angle and then side, angle. If we count it this way, it'd go angle, side, angle. So two angles and the side that's in between those two angles of one triangle are congruent to the same thing, two angles and an included side in the other. Then those two triangles are congruent. That symbol means congruent. Okay, and that's angle, side, angle, and then there's one more, and that's angle, angle, side. And that would look like this picture, where you have, again, two angles and a non-included side. So just another side of one triangle are congruent to two angles, and the same thing, I'm just going to draw an arrow, of another triangle, then they're congruent. Okay, basically it's just angle, angle, side. Angle, angle, side. Now again, we can't say angle and skip around and say angle, side. You know, some people want to go angle, side. What am I doing? Oh, angle, side, angle. Remember this side they share. So this is the side that we're talking about. So angle, side, angle. You can't do that because we're skipping so much in the process. But if we come here, angle, the very next thing is an angle, and the very next thing is a side. Angle, angle, side. Okay, so right now we got four that we can use in these type of problems. And these are the four right there. Let's take a look at if we would have angle, angle, angle. Or in this case, we just have two angles, but we know that all the angles add up to 180 in a triangle. So if those two are the same, then these would have to be the same. So I'll just go ahead and fill that in. So really, if you're given two, you can figure out the third, so it doesn't really matter. But if we're given all angles, and you can look here and see that these are not congruent. I mean, this is a bigger version of that triangle. And this goes back to what we learned last week, is that when all of the angles are congruent in each triangle, we cannot prove that they're congruent. This only means that they're similar. Okay, remember, similar triangles have the same angles but proportional sides. Maybe if this is 4, then that might be 12, and if this is 5, that might be 15, or so on and so forth. They just will be similar. So angle, angle, angle is not something you can use to say that these triangles are congruent. And then there's this other postulate. We got angle, side, side, angle, side, side, and you'll notice that this spells ass, and there is no ass postulate. It's a pretty easy thing to remember, and that's not even something that math teachers came up with. It just works out that way, which is pretty funny. But if you look here at this example, if you have an angle and the side and a side, and you look over here, and I tried to make this exactly to scale, but we got this same angle right here. This looks like it might be about, I don't know, maybe 40 degrees. I'm just guessing. And this is that same angle. We'll say maybe this is about 40 degrees too. So you have the same angle, but just because the angles are the same doesn't mean these sides have to be the same. You see how this side is about the same, but this is a shorter version. And so even though this is a shorter version of that side, it doesn't affect the angle. So this is just a weird case where you have three parts, but it doesn't work out. And it just never works out when it's ASS, angle, side, side, angle, side, side. It does work out in one special circumstance, and we'll get there eventually. We'll learn what that special circumstance is. But for right now, the only things that work are side, 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 angle, side, angle, angle, side, angle, side, angle. Okay, angle, angle, angle does not work, and angle, side, side does not work. Okay, if you get an example like this, you would say they're not congruent, or we don't have enough information, we can't prove congruency. Okay, I just put down here a proof toolkit. As we get more into these proofs, you're going to see some of the same tools that we're using over and over again. And I mean, really, that's these four things that I just wrote down is that you're going to see. But from doing Friday's classwork and Thursday's homework, you'll see you also need to use sometimes the fact that you have shared sides. That was something you used a lot on Friday if you did your classwork. That popped up a lot. What else popped up? Vertical angles pop up quite a bit. We had a couple instances where you had alternate interior angles. And make sure that when you're using alternate interior, you can only use this when the lines are parallel. Okay, there was one example where they were alternate interior, but it didn't say anything about parallel, so we couldn't use that. If we flip back, I think that may be it. For what, if we come across something else, we'll add it. But these things pop up an awful lot, and so be familiar with these things and what they are, and you use them over and over again. All right, flipping over onto the back. And let's look at some examples. So are they congruent? Okay, well, let's see. They look like they're the same. But we've said over and over in this class, looking like is just not good enough. And so we have to prove it. And so with all of these, the easiest thing in the world is just start with what is given to you. And in most instances, you'll get half the problem done just by doing that. Looking at right now, these tick marks show us that R is the same as A. And anytime you're given tick marks, that's just what they give to you. It's always going to be given. Okay, now we see that this is 90, and we can go ahead and put that that's 90. We know that because that's a linear pair, and so you can either put a linear pair or given. It doesn't really matter. Now, what some people were noticing is you can't just say angle D and angle D, because we don't know which ones we're talking about here. So here we said angle R because that's the only angle R that's there. And if we say angle R, you know exactly that you're talking about this. But we can't just call this angle D. We have to be more specific. We have to say angle RDE, so we know we're talking about this one. And remember, the vertex has to be in the middle. You couldn't say RED. That would be this one. So again, we could have went EDR. But RDE, same thing, as long as this is in the middle. Now we'll go ADE. And remember to put an angle in front so that I know you're talking about an angle, so you know you're talking about an angle. And this was given to us, kind of. I mean, we did put that these have to add up. So if you wanted to, you could do a linear pair here. Or supplementary is fine. Okay, and so now we're a place where we need one more thing. You know, we got an angle and we got an angle. We need something else. And here's where it goes back to that toolkit of just being familiar with those things, just being on the lookout for, oh yeah, they share a side. They come together and they're sharing this thing. DE is the same in this triangle as it is in that triangle. And so we know DE is going to be the same thing as itself because these two triangles share it. Okay, so we got three things, and that's all we need. Now remember, just because we write it in this order here doesn't mean that's what it's going to be, because we could have written this in any order. So let's look at the picture to see what we have. We have angle, the very next thing is an angle, the very next thing is a side. Angle, angle, side. So in fact, we did write it in that same order. So now we're just going to put triangle. See, that's why we put these symbols, so we know, okay, here we're talking about an angle, here we're talking about a triangle, but we can still call this RDE. We can call it anything, it doesn't matter, just as long as we match it up. So if we go RDE, we want to go ADE, triangle ADE. Okay, the last step of these is always going to look like that. You're going to prove that the triangles are congruent because of one of these postulates. All right, let's come over here. Now, we can look at example 2 and say, and you should, are they congruent? No. I mean, this is a lot smaller than that one, so no, they're not congruent. You could just say no, or you can't prove it. Okay, I've seen some people put NA, sure, any of that works. Just save yourself some time and just say you can't do it. Okay, if you went through the problem, I mean, you could go through and start and say, okay, N is congruent to C, that's given. B is congruent to X, that's given. And then you may stop and say, well, can we get a side? And I've noticed that some people just come through here and mark stuff. You can't just do that. That wasn't given to you. You put that mark on the paper.